Hi everyone. Today a look at Faraday's law. This is a law that was first explored by English chemist Michael Faraday in the early part of the 19th century, early 1800s. Michael Faraday is a really important figure in the history of science, maybe like top 10 important people in the history of science. He's a big deal. We have this new equation, N, the moles of electrons, equals I times T over F. N, the moles of electrons. It's really important to emphasize that it's moles of electrons. It's not just moles in general like we've encountered before, specifically moles of electrons. I is the symbol for electric current. The units for current are amperes, which we often just call amps. If you don't have a physics background, this might be a little bit tricky. The symbol is I. What we call it starts with a C. I is the symbol, but it's for current with a C, and the units are a capital A. So there's not really a strong connection there. That might throw you off. Pay attention to that. T is the time in seconds. I need to stress that, in seconds. Lots of questions maybe will provide us with a time in minutes or possibly even hours. Likewise, if we turn out that we're solving for the time, we need to know that the equation will give us the time in seconds, but if a question asks us how long is it going to take in minutes, we need to do that conversion. Be careful there. F, the denominator here, this capital F, is named in honor of Michael Faraday. It's Faraday's constant. 9.65 times 10 to the power of 4 coulombs per mole of electrons. Because that's a constant, we do not need to memorize it. We can find it on page 3 of the data booklet. Here's an example. A current of 2.00 amps flows through a circuit for 30 minutes. Determine the number of moles of electrons involved. Notice that for this question, I don't need an equation. There's no mention of any specific chemical. That's kind of nice. It's really using this formula, it's a very mathematical problem. The possibility does exist that we might be solving for the current, or in a different scenario, a question could ask us to solve for the time. This one asks us for the moles of electrons. Determine the number of moles of electrons involved. I'm going to take it slow. We have a current of 2.00 amps. That's I. Again, if you don't have that physics background, if you're not used to this relationship between current and amps, be careful. I is the symbol for current, but the units are A. That's a little bit strange. It flows through a circuit for 30 minutes. That's obviously the time. T, but again, big heads up. The time when we use the equation must be in seconds. Determine the number of moles of electrons involved. Find the moles of electrons, moles of electrons. So we're not going to have to manipulate the equation for this particular question. Of course, as I already mentioned, sometimes we might be solving for the current or the time. So we have moles of electrons. It's the current, I, 2.00 amps. And we have the time, 30 minutes, which we must convert to seconds. I'm going to write it like this. We have 30.0 minutes times 60 seconds per minute. That conversion. This is all divided by Faraday's constant, a brand new constant for us. We're not used to it. 9.65 times 10 to the power of positive 4 coulombs per mole of electrons. An extra thing just to add is that the algebra for our units here doesn't exactly work out because of these coulombs. Okay? An amp second is a coulomb, and that's really a physics kind of a thing. Let's not worry about the units. We have it set up to solve for moles of electrons. Let's just trust it a little bit. Okay, I have my calculator. Let's type away. 2 amps times 30 times 60 divided by 9.65 times 10 to the power of 4. I end up with 0.037305699. Our raw answer, we're going to follow our traditional significant digit rules here. 2.00, that's 3 significant digits. 30.0 minutes, that's 3 significant digits. So our answer, rounded off so that it has 3 significant digits, is 0.0373. And what did we find? Moles. Specifically, that's the moles of electrons. So this is Faraday's law. It's our first time to encounter it. Moles of electrons is I times T over F. We'll be asked sometimes, like this example, to solve for moles of electrons. A different scenario would ask us for the current or the time. Current might take a little bit of getting used to. ICA. Big thing, the time must be in seconds. It is going to be very common for us to be given questions that have minutes, possibly even hours, which we must convert into seconds. Finally, we have this constant, 9.65 times 10 to the power of 4, which we can find on page 3 of the data booklet. And I hope that helps.